Clay soil fails gardeners not because it lacks nutrients, but because it suffocates life. If you have worked clay long enough, you know the cycle. Wet, it turns to glue. Dry, it hardens like fired brick. Roots struggle, water stagnates, and no amount of compost seems to change the texture. What finally breaks this cycle is not more organic matter alone, but a specific kind of fermentation that older farmers relied on and modern systems quietly abandoned. It was considered improper in some circles because it smelled, foamed and broke every rule of tidy gardening. Yet it worked with ruthless efficiency. The ferment was never meant to be polite, because clay itself is not a polite material. Historically, clay soils were amended with aggressively fermented plant slurries made from weeds, leaves, chaff, and sometimes manure. These mixtures were not sealed carefully like Bokashi. They were allowed to rot, sour, and partially anaerobically break down in open or loosely covered vessels. The goal was not preservation, but transformation. This ferment attacked clay's greatest weakness, its tendency to bind too tightly and exclude air. What makes this ferment different from Bokashi is the end state, not the ingredients. So, Bokashi preserves organic matter through controlled fermentation, delaying decomposition until it reaches the soil. This forbidden ferment actually finishes the breakdown before application. By the time it touches the ground, complex plant fibers are already partially liquefied. Acids have formed, and microbial metabolites are, well, abundant. When introduced to clay, these compounds immediately begin separating soil particles, allowing aggregation instead of compaction. The chemistry of the ferment changes how clay behaves within days, not seasons. Clay particles, you see, carry these tiny electrical charges that make them stick together quite stubbornly. But the organic acids that are produced during aggressive fermentation, well, they actually help to neutralize some of these charges. This, in turn, causes the clay plates to loosen up and reassemble themselves into crumb structures, rather than forming those dense slabs. Historical farmers, they noticed this effect pretty quickly. Fields that were treated with fermented slurries drained much better after the next rain. And interestingly, they also cracked a lot less during those dry spells. Preparing the ferment, honestly, follows a logic that's much older than modern soil science. First, green plant matter is chopped finely, just to expose as much surface area as possible. Fast-growing weeds, grasses and leafy plants work best here, since they're packed with soluble sugars and minerals. This material is then submerged in water, along with a small amount of carbohydrate, like molasses, crushed fruit, or, well, even a bit of stale bread. The container is covered loosely, never sealed, and left somewhere warm for, about 1 to 2 weeks. The smell that develops becomes sharp, but not putrid. That sharpness, actually, is a good sign. It signals active organic acid production. Application now is where most modern gardeners go wrong, usually by being a bit too cautious. So, this ferment is, usually diluted before use. About 1 part ferment to 10 parts water, give or take. You don't pour it directly onto plant leaves, mind you. Instead, it's best applied to bare soil, pathways or beds before planting. For existing beds, you'll want to water it into the soil during the cooler parts of the day. Historically, folks preferred to apply it just before a rain, which helps the solution soak in deeply and avoids any surface runoff. Now, clay really responds best when the ferment is followed up with some good physical protection. After application, soil should be covered with mulch, straw, leaf litter, or even cardboard. This traps moisture, feeds microbes, and, well, prevents the clay from recompacting as it dries. Within weeks, earthworm activity increases, fungal threads appear, and the soil becomes noticeably easier to work. This rapid change is what gave the ferment its reputation. It did what years of compost could not. The reason this method fell out of favour was not failure, but discomfort. It smelled. It looked messy. It violated the aesthetic of clean gardening. As commercial fertilizers and sealed fermentation systems became popular, these open ferments were labeled crude or unsafe. Yet, farmers continued using them quietly because they solved real problems quickly. Clay soils that resisted ploughs became productive without deep tillage. You see, this ferment really excels because it feeds structure before it ever feeds the plants themselves. Plants grown in treated clay. Well, they show stronger root systems, improved drought tolerance, and far fewer nutrient deficiencies. This all happens because, at last, the roots can finally breathe and explore. Nutrients that are already present in the soil become accessible once the structure improves. The ferment doesn't actually replace compost or minerals, it just unlocks them. Modern gardeners can, adapt this method without abandoning safety or control. Using plant-based materials avoids pathogen risk. Dilution, it prevents root damage, and applying it seasonally limits build-up. A soil that was once avoided becomes workable, resilient, and biologically active. This is not a miracle solution, mind you. It's a structural correction grounded in how soil actually functions. What makes this ferment endure is, speed paired with humility. It does not claim permanence. It prepares the soil so other practices can succeed. That is why it outperforms Bokashi in clay. Bokashi feeds life. This ferment creates space for life to exist. If you value historically grounded, results-driven methods that solve real soil problems without marketing noise, subscribe to Botanical Bliss, share this guide with growers who are still battling clay, and help preserve the practical knowledge that transformed land long before modern systems appeared.